Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are doing problem number 6, question number 6 from review and by request. So I took the liberty to draw do a graph of what exactly is going on here. Let me go ahead and write that, review n. Okay. And so we have the function ln 4x over x, and that is this blue graph right here. Point is p 0.250 and q are on the curve of f. So I went ahead and graphed p for us right there. And then q is also on the function f of x. Where is it? Well, the tangent to the curve of f at p, so I have constructed that tangent line for us. It's at p, meaning it's through the point p, is perpendicular to the tangent at q. So that means that this tangent line is perpendicular to the tangent line that q is on. Okay, and where is q? Well, this line is tangent at the point Q, and even though it doesn't look like it, and that's just because of the window shape of our calculator, this is perpendicular to this. So this tangent line is perpendicular to this tangent line, and so we're looking for that point Q. So we need to find that x coordinate, and we can use that using derivatives, and then we can substitute it into the original function here to find the y coordinate, and that will be our q. Well, we know that lines that are perpendicular have slopes that are opposite reciprocals or negative reciprocals. And how do we find slope in calculus? Well, we use the derivative and substitute in the coordinate. So if we find the slope at, not 0, but the slope of the tangent at 0.25, well, that's equal to negative 1 over, and I'm calling this the x coordinate of q, f prime of x. They're negative reciprocals of one another. So that's the strategy we're going to take. Okay, so obviously we have to first find the derivative of the function, and we'll have to use the quotient rule. And if f equals u over v, then f prime is equal to v du minus u dv all over v squared. Okay, so in this case, f prime of x is going to equal vx times the derivative of u. Well, the derivative of natural log is equal to 1 over whatever we're taking the natural log of, or the log of, and that's 4x, and then multiplied by the derivative of 4x, which is 4. That's just the chain rule, minus u ln of 4x dv. Well, the derivative of x is 1 all over v squared, and if we simplify that, it comes out sort of nice. The 4's cancel, x over x cancels, or x divided by x is equal to 1, minus the natural log of 4x all over x squared. So we need to find, like we said before, the slope at p by substituting in the x coordinate. So f prime of 0.25, and I'm just going to save us some time here. If I substitute this into the derivative, I get 16. So that means the slope of tangent line through Q equals negative 1 over 16. So let's think about that. Okay, the slope of the tangent line through Q is negative 1/16. Well, this derivative gives us the slope of every tangent line on the curve of f of x, including right here at Q. So all I have to do is find out where the derivative, which is 1 minus the natural log of 4x over x squared, is equal to the slope at Q, which is the negative reciprocal of the slope through P, because they're perpendicular lines, negative 1/16. And I'm going to do that by graphing. So I'm going to go to my graphing calculator. Let's just do a new one. So control, I can just click here. Okay, so let's see, tab. I'm going to graph negative 1/16, which is going to be a horizontal line, very close to 0, but that's okay, because I just have to find an intersection. And now I just need the derivative, which is 1 minus ln of 4x. So let's put that in. It's 1 minus ln 4x over x squared. Do my fraction. 1 minus the natural log of 4x over x squared. Boom. Okay, let me just move this out of the way for us. It's a little annoying. And I just need to find that point of intersection right there. Menu, analyze graph, intersection, boom, boom. And you can see my x coordinate to 3 sig figs is 0.701. The x coordinate of Q is 0.701. And let's go back here. So that looks about right. Now you won't have this, but I'm just for explanation, looks like Q is right at about 0.701. So we can feel, or I feel fairly confident based on this. So we know that the x coordinate of Q, let me get my pen back. So x coordinate of Q is 0.701. And then to find the y coordinate, I have to go back to the original function, because Q is on the original function, by finding f of 0.701, which I would have to substitute back into the original function, which is ln of 4 times that over x. So let's do that. That's not too bad. Back here, my fraction, natural log of 4 times 0.701 all over x, which is 0.701. Boom. And I get 1.47. So 1.47, and we have found what we have been asked to find, the point of Q. Oops. All right. So hope you enjoyed that. Now we know how to do it. Let's celebrate a bit. Bang. Oh, got to get out of there. Boom. A little more. This is how we do it. I am out. Hope you enjoyed it.